Hello, everybody. About 17 hours ago, I posed a math question that I thought was a pretty simple math question. Cue music.
It's the Diners.info TV show. It's the Diners.info TV show.
And the math question is, if the COVID-19 test is 70% accurate, and I have the test done 10 times, and I get 7 positives, okay, that's 7. This is how I used to taught my daughter how to count, right? 7 positives and 3 negatives, right? 7 positives and 3 negatives. Do I have COVID-19? And then actually, I'm asking, what's the probability? What is the percentage probability that I have COVID-19? Now, we can also do this with pregnancy. I think it's a fairly easy math problem, okay? But one person does the test 10 times, gets 7 positives and 3 negatives, and the test is 70% accurate. By 70% accurate, I'm saying that somebody who is pregnant or has COVID-19, right? If we had 10 pregnant women who came in and they took the test, only 7 of their tests would be positive. If we have 10 not pregnant women, then 3 of those tests would come out positive, right? If you're not pregnant and it's a 70% accurate test, right, you're going to have 7 correct results and 7 correct results and 3 incorrect results. So it's sort of just flip-flops, right? If I'm pregnant and I go in, 10 pregnant people go in, 7 of them are going to get the correct result, and 3 of them are going to get not pregnant even though they're pregnant. COVID-19, 7 of them are going to get you have COVID-19 even though they have it, and 3 of them are going to get a false negative. Now, a good friend of mine, long time friend of mine, said, hey, maybe I'm not looking at it from the correct medical standpoint. I wouldn't say that. I would say, I'm not going to say what the negative evaluation was, because it's sort of what do you mean by accuracy? Now, the way I remember it is that that's the term that they use on the pregnancy test, right? Don't they say it's like 99.8% accuracy? Is that the word they use? But we have sensitivity, specificity, positive predictive value, and negative predictive value, okay? And so here are a bunch of, here's a table. And the way that these numbers would play out, right? We can also take 10, let's do COVID-19 this time, or should we make them pregnant? Let's do COVID-19, okay? So 10, and the thing that I kind of didn't like about this Penn State Eberly College of Science article is that in the hypothetical example 1, screening test A, 100 people are tested for the disease, 15 people have the disease, and 85 people are not diseased. Now, does that mean that was that the test result, or do they already know that they either have or don't have the disease? For me, that is something like, I don't know, they've got like bulging nose syndrome, right? So you've got 15 people with big bulging noses and 85 people who just don't have big bulging noses. So in this hypothetical example, it kind of looks like they're putting the cart before the horse, because they know if the people have the disease or not. So what's the point of doing the test, right? But okay, 15 people maybe tested that they have it and 85 people don't. And then there are these definitions. Sensitivity is something that shows the probability that a test will be positive if if you're actually positive, and they're calling specificity the probability that you're going to get a negative result if you're negative. So to make it fit into this table, we're going to take 10 people, and I'll put it out onto this table, and then we can go back to my original question. So if 10 people are sick, and they go and they take this test that I'm talking about, that I called it had a 70% accuracy, and I was told that I was thinking of it incorrectly. Okay, this is how I'm thinking of it. 10 people go in, they're sick. 7 of them get a true positive, and 3 of them get a false negative, right? So that would be 7 people in column A, or in field A, I'm not sure, box A, and since they were sick and their test came back negative, in box C, there are 3. So A has 7 and C has 3. There are 10 people who do not have COVID-19 who go in and they test. 7 of them are correct negatives, right? True negatives. So that means 7 in box D, and 3 of those are going to have false positives. Okay? So if the table that you see there, it's going to look like this, and it's probably going to be reversed for you. And you know what? I don't need to. It's not going to work very well like that. So now you know that we have 7 true positives. Okay. 3 false positives, 3 false negatives, and 7 true negatives. Okay, now if we do that, then the sensitivity is actually 70%, and the specificity simultaneously is also 70%. I called that accuracy. I don't know if that's the correct term. So now, with a test that's like that, I'm calling a test that has that constellation 70% accurate. It's got a 70% sensitivity and a 70% specificity in medical terminology, right here, using the epidemiological research methods of Penn State Eberly College of Science and this table here, right? So we get 70% sensitivity and 70% specificity. So back to my original question, if somebody who does not know, okay, if you don't know if you have COVID-19, or if you don't know if you're pregnant or not, and that's the accuracy, specificity, sensitivity, that's the effectiveness of the test, right? If it's 70% accurate, I'm calling it that, and I get the test done 10 times, and 7 times I get a positive, and 3 times I get a negative, do I have it? And at what proportion likelihood do I have it? That's my math question, and it stands. I think I figured it out. I would just like to see how other people calculate it, and if I can learn something. And thank you very much for your time and attention. Okay, take care. Bye.